All right, we're doing part 2 for the morning review. Again, we're doing part 2 for the morning review. Starting off with number 9 because I brushed through that one yesterday. Okay, so as I was saying, if you have two logs or two ln's on opposite sides with a constant, get the ln's together so you can eventually do the wraparound. So you would add the ln x to the other side. And then it's gone here and gone there. Do you guys see that? And then you're left with 2 equals, and I'm going to bring that exponent up. ln of e over the 4th root of 5, and all this in parentheses raised to what power? 4th. What's going to happen with that 4th root raised to the 4th? It's going to cancel eventually. Plus ln of x equals 2. Now, in order to either drop the log or wrap around, I need only one log on each side. Is there one log here or 2 logs? 2. Do we have the powers and the rules to condense them? Addition becomes what? So 1 ln, and then e to the 4th over what? When I distribute, over what? 5 times, I'm just going to put x over 1 for now, equals, yep, it gets rid of the radical. All right, now, is it drop the log or wrap around? Wrap around. What's the base here that I don't see? Don't say 10. E to what power? Equals this big piece here, e to the 4th x over 5. All right, now we're just about done, and almost done. Yep, e squared equals e to the 4th x over 5. I want to get x by itself, so what do I do next? By 5? Gone. 5e squared equals e to the 4th x. And what do we do next? Divide by e to the 4th. And you have choices here. I like to just leave it with e, but technically you can, and you are allowed to plug this in your calculator. 5e squared divided by e to the 4th. I'm just going to simplify by subtracting exponents. 2 minus 4 is positive or negative? So instead of doing that, can I do 4 minus 2 and stay at the bottom? So 4 over what? Sorry. Magic. 5 over what? E squared. You can, oh, geez, Louise. That 4 is like wanting to be on the paper. It's up to you. That's what I said. You can plug it in or leave it like this. This is why I like to see it's easier when I'm grading. But if you plug it in your calculator, you can. 5 divided by e squared. Got it? Any questions on that one? Okay. Moving on to number 10. Solve for m in terms of k. We saw this one again just once or twice in homework and in notes. Solve for m. So it's like solving for x. So I'm trying to get m by itself. That means I want to get everything that does not have an m to the other side. Does this have an m? So I'm going to leave it. Does this have an m? So what do I do to it? Subtract it. (8k minus 7 equals negative log base 4 of m). All right, you have choices on how to get rid of that negative. Any thoughts on what to do? Divide by negative. Is everyone okay with that? All right, divide. You can keep the log, right? The log will stay there for now, yes. Divide by negative 1. So it's up to you on how you write this. You can write it as 7 minus 8k or negative 8k plus 7. Does it matter? No. Negative 8k plus 7 equals positive log base 4 of m. All right, what am I trying to solve for again? M. Look at where m is placed. What kind of solving do I do? Do I drop the log? Do I wrap around? Do I raise both sides to the reciprocal power? Wrap around. What's the base? Raised to what power? Equals what? And is at that point, are you done? 4 raised to the negative 8x plus 7 equals m. solve for m in terms of, and I changed my k to an x. Solve for m in terms of k, meaning k is in your final answer and you have m by itself. Yeah, that's the answer. All right. Next one. Log base 3 of 5 equals m. Log base 3 of 8 equals n. Do you guys remember the should know that you always write down? It's not always the same. In this case, what is it? Louder. Log base 3 of equals 1. What and how, why does she pick log base 3 of 3? I could use log base 5 of 5. Why does she use log base 3 of 3? Because those are the bases they give you. All right. So if this were log base 7 of 5, here I would have log base 7 of 7 equals 1. All right. Remember, we could use multiplication, division, and I'm going to use that symbol for exponents. 40, 5, 8, or 3. 5, 8, and or 3. Any combination?
5 and 8.
5 and 8. Log base 3 of 5 times 8. Does that mean it's m times n? No. Don't forget, we have to use our log laws. And what do I do here for the log laws? How do I rip it apart?
You add them.
Add them. Good job. Log base 3 of 5 plus log base 3 of 8. Therefore, my final answer is what? M plus n. All right. 25. Now, kids will say, well, 5 times 2. No, 5 times 2 is not 25. 5 times 5 or 5 squared. It's up to you and how you want to write it. Log base 3 of, what did you say? 5 times 5? All right. 5 times 5. Does that mean it is m times m?
Wouldn't it be m plus m?
Right. You're right. I bring it up for a reason because kids are like, oh, 5 times 5 and 5 is m times m. No, you have, remember, use your log laws. Log base 3 of 5 plus log base 3 of 5 is m plus m, which is not m times m. What does it come out to be?
2m.
2m. All right. I just want to show you really quick, what if you did do it as a squared? Log base 3 of, do you agree 25 is 5 squared?
Yeah.
Can I plug in the m and say, oh, therefore this is m squared? No. What do I have to do with this 2 first?
Take it to the front.
Take it to the front. 2 log base 3 of 5. What is log base 3 of 5? Is it the same answer?
Yeah.
All right. Yes.
For the test, do we have to do all the work? Like, I can just think that.
I need to see something. If you just go straight from here to here. At the very least, this piece here, the last piece before you plug your letters in. Oh, Nick. Oh, my goodness.
Recovery points are going to be on this test, right?
Yeah. Yeah. All right. Okay. Now, this one, kids struggle. 5 and a 5. What do I do? How can I rewrite this?
You can do 5 and 1/4.
5 to the,
1/4.
and why would I do this? To plug it in now or to bring the 1/4 to the front?
Bring the 1/4 to the front.
1/4 log base 3 of 5. What's log base 3 of 5? So 1/4 m or m over 4, depending on how you want to write it.
So, like, the fourth root of m is not working?
No. No, because that would say m to the, that means you would have plugged it in right here. You would have said, oh, m to the 1/4, which is not okay. It's 1/4 m, or m divided by 4. Be careful. Okay, 72. Can I use 5, 8, or 8 and what? Okay, but do I have a 9 over here?
No.
But do I have it here in the should know?
Yeah.
Yes? So log base 3 of 8 times 3 squared. Is 3 squared 9? Yeah? Or if you wanted to, could you say 8 times 3 times 3? Is that a possibility as well?
Yeah.
All right. All in all, can I plug the letters in now, or do I have to rip them apart first? Okay, log base 3 of 8. Plus or minus? Plus log base 3 of 3 squared. Or again, if you wanted to, you could do log base plus log base 3 of 3 plus log base 3 of 3. All right, what's log base 3 of 8? Plus, where does this 2 go? 2 times what's log base 3 of 3? So n plus 2. Did anybody do it the other way on their own? 3 times 3 instead of 3 squared? Did you get the same answer? No?
What?
Yeah, okay, yes. I asked, did anybody do it doing 8 times 3 times 3? Karina said yes, and she got the same answer. All right, are we good and ready to move on?
Yeah.
All right. Graphing, all you really need to know for the graph is which one's exponential growth, which one's exponential decay, what does the graph look like. That's all I'm going to do quickly. 2/3 is bigger than 1, or as long as your exponent's positive, which it is, you look at your base. Is 2/3 bigger than 1 or smaller than 1? Smaller, so growth or decay? Decay. So you just need to know it looks like that. All right. 3/2, bigger than 1 or smaller than 1?
Bigger.
So you just need to know it looks like
So we
that.
just have to do
You
it.
just need to know what the growth looks like. When is it getting closer to, in this case, when is it getting closer to your x-axis? The x is getting bigger or smaller?
Or bigger.
Bigger. On this side, when is it getting closer to the x-axis? As x is getting smaller. All right, makes sense? Now, just be careful. What if I gave you something like this? Y equals 2 to the negative x. Kids are like, oh, 2's bigger, so it's growth. What's tricky about this one? So this would be y equals 1/2 to the x, in which case it would be a decay. So be careful if that exponent's negative and they're asking about growth and decay. All right, questions before I move on?
What is it as an extra credit on the test?
This one down here. Oh, well, you get to pick it. It's up to you if you pick that one. All right. What interest rate is needed to triple the value of an initial investment if the interest is compounded monthly for 20 years? The two formulas will be given to you. I'm going to write them up here really quick. A equals P 1 plus R over N raised to the NT. And then A equals P E raised to the RT. You do need to know what the letters stand for. You do need to know when to use which one. When do I use this one? And when do I use this one? Anyone know? First, second?
Continuously.
Which one's
The
continuous?
one on the right. For
Compounded continuously. So if they use the words compounded continuously, this is the one. If they use compounded monthly, semi-annually, quarterly, it is this one. There's going to be nothing tricky. It's going to say either monthly, which is 12, quarterly, which is 4, semi-annually, which would be 2. Nothing tricky. It's like, oh, what do they mean? No, it's 2, 12, 4, once a year. All right. What interest rate? Okay, let's quickly go through what they stand for. A is the answer after time has passed. P is your initial amount. R is your rate. What does N stand for?
Number of times compounded.
Good. Number of times compounded, and T is the time. All right. What interest rate is needed to triple the value of an initial investment? Did they give me the initial investment?
no.
What do we make the initial investment when they do not give it to us? 1. And what is the triple amount going to be? 3. All right. Rate, do we know, or is that what we're looking for? Number of times compounded. Compounded monthly. So 12 times per year. For how many years? 20. All right, so let's plug this in. 3 equals 1 parentheses 1 plus R we don't know over N, which is 12, raised to the 12 times 20. And you will need your scientific calculators for this one, so make sure you have them out and on and ready. Okay, I'm trying to solve for R. Is R a base or an exponent? Where is the R, the base or the exponent? Okay, so I can at least divide by the 1. Is dividing by the 1 going to change anything? No. So 3 equals 1 plus R over 12 raised to the, what's 12 times 20? 240. All right, I'm going to cover the 240 for just a second. If I had this, 3 equals 1 plus r over 12. Can you guys tell me how you would solve that? Wait, what? Before multiplying by 12 over 12, could you subtract the 1?
Yeah.
Subtract the 1 and then multiply by 12 over 1 on both sides? Do you guys agree?
Yeah.
All right, so that's what I want to do eventually. I want to subtract the 1 and multiply by 12, but what's preventing me from doing that right now? So do you guys remember what we do to both sides to get rid of the exponent? We multiply or raise. Raise both sides to the reciprocal. That freaks kids out when they see a number. They're like, what? 1 over the... That, yes, you can do that. You're taking the 240th root of 3. So, and why do we do this? To cross out the 240. Now, how do you plug this in your calculator? 3, my exponent key is here. You have to look for it if you're using a different calculator. I'm going to clear, and I'm just going to ask that everybody make sure you're in Classic because it's easier to work with. So go to Mode right now, check that you're in Classic, clear it, and let's plug this in. 3, exponent key, use your fraction key instead of your division key. 1 fraction 240 equals. Would you say that's really close to 1? Yeah, we're not going to round it to 1 because we leave this decimal in our calculator as long as we can anyway. So 1.004, I'm going to put dot, dot, dot so I don't have to write it all. Now the whole reason we did this was so that we could do what? Subtract the 1 and then multiply by 12. Go ahead and do that now. And it makes sense. Kids are like, well, this number's really small. Yeah, it's a rate. The rates should be really small because they're a small percentage that are small decimal that you make into a percent. All right, what do we have? 0.0.
So we'll be rounded to 6%.
0.055. I leave it like this. Is that right? 0.055. And then what is that as a percent?
6%.
5.5. All right. Make sense? All right, so where do kids get stuck on this one? Right around here. They don't know that they can raise both sides to the 1 over 240 to the power because it's 240 is a big number. If it was squared, they would know, oh, square root both sides. If it was cubed, oh, cube root both sides. If it was to the 3/2, oh, raise both to the 2/3. But when they see the 240, it stumps them. All right, questions? Okay. Next one. A radioactive substance has an initial amount of 160 grams. After 5 hours, 37 grams still remain. Write an hourly exponential decay function in this form. I give you a hint. Then solve for the number of hours for the half-life of the substance. This is the final question. You get to pick your extra credit on the test, so if you want this one to be your extra credit, you would mark it.
How many extra credits?
You get to pick 2. Okay.
That one test where we got 5.
All right. Okay. So the hint is plug in information and solve for B. All right. So y equals AB to the x. This is dealing with half-life. So obviously, what letter represents the time? And then use T here. X. X is your time. All right. Now here, P was always the initial amount. It's not always going to be P. In one of our worksheets, there was an A naught. Do you remember that? So, but the letter here, the first letter on the other side of the equal sign is always your initial. What's your initial here?
A.
A. What is Y? Your answer after the given time. Okay, just like all the ones we had. Answer after given time. A is the initial, X is the time, and B is your decay or growth rate. All right, so let's plug in. A radioactive substance has an initial amount of 160. Where do I plug in the 160?
A.
And it tells us to solve for B, so I don't know what B is. After 5 hours, where do I plug in the 5? The X. 37 grams still remain. Is this growing or decaying? So in the end, should my B be bigger than 1 or smaller than 1? All right, how do I solve this? Divide by 160. Remember to leave that decimal in your calculator. Go ahead and plug that in now. 37 divided by 160. Right, you have to divide first before you do any exponential power, unless it's in parentheses. 0.23125. And then what do I do? Do I divide by 5, raise to the 5th, raise to the 1/5?
I mean, you can raise it to 1/5.
Raise to the 1/5. Now, I had a kid say, can I take the 5th root? That's exactly what we're doing. If you know how to use the 5th root key on your calculator, go for it. If you don't, most of you know how to plug into the power. B equals, so that decimal that's in here, exponent key, 1 fraction 5. And let's do 3 decimal places. What do you get? 0.746. Okay, is this your final answer? No, this was just the hint part. What do they want us to find? The number of hours for the half-life of the substance. Okay, are we ready? I'm going to use my formula again. Y equals AB to the X. What did I just solve for and find that I can now plug in? Y equals A parentheses 0.746 raised to the X. I want to know the number of hours. What am I solving for? X. I want to know the number of hours it takes for the half-life of the substance. What is the initial amount?
160.
And what would the answer be if I'm looking for the half-life? 80. Do you guys see how we got 80? Divide by 2.
Yeah.
How look?
Is this gonna be on the test?
This yes, it is. And I said you could choose 2 extra credit. This if you choose this one, this could be your extra credit.
There are only one.
Yes.
Nice.
All right.
How would you know like which variable?
Yeah, like A, B, and X and Y.
Okay. What I said earlier, even last week, the letter here, whether it's A naught, P up here, whatever it is, the letter here is always the what amount? Initial. This is always the answer after a given time. That only leaves X and B. We all know that the X is the time, the exponent's the time,
So then B is.
the growth rate or the growth rate or decay rate, which is, we got decay, which makes sense. All right, so Y is 80, A is 160, 0.746 raised to the X. What do I do to both sides? Divide by 160, gone. Divide by 160. What's 8 over 16? Does that make sense? It equals a half because we're looking for the half-life.
Yeah.
Yeah. That's why when they don't give you the initial amount, we just put 1 here and half here, and it would have worked out the same way. All right, what do I do to both sides? Divide by 0.746, reciprocal power, log of both sides. How do we know that this is a log of both sides? Because the exponent's the variable. And the reason we do this is to do what with the X? Bring it to the front. And after you do that, are you ready to solve? Yes. Divide by log of 0.746. Don't forget to close your parentheses. X equals, and think about what your answer should look like. It took 5 hours to get to 37 grams. I don't want to get that small. I'm trying to get to 80 hours. Should it take as much as 5 hours or less or more? Less. And what does the answer come out to be? 365 hours. All right. Questions?
Number 7 again.
Yes. Do you want me to do that exact one or the one that was on the quiz?
I'm just confused about the exponent, the 2x.
Okay.
That part.
When you see this on the test,
Gotta substitute.
yes, when you see this, whether it's 3 to the x, like over here, they were exactly the same, right here. 3 to the x, 3 to the x, and you guys said, oh, use substitution. That's easier to see because they're exactly the same. When they're not exactly the same, there's going to be a 2 there on it or something very similar. in which case you're still going to use substitution, but you want to do this first. Do you agree that 3 to the x squared, you multiply the powers? It's not x squared, it's x times 2, which is 2x. So are these two things exactly the same?
Yeah.
Yes. The reason we do this so we could plug the u in here and the u in there, so it's u squared minus 30u plus 81 equals 0, in which case we could double bubble. Now, the only thing is, can't remember what it looks like on the test, but here they were really easy. 3 to the x equals 27 and 3 to the x equals 3. It was really easy to say, oh, that's 3 and that's 1. What if you got something like 3 to the x equals 17? You do not give up, Nick. You know how to do this. What do we do?
Do we take a log?
We take the log of both sides. There you go. So that this can come to the front and then divide. Log of 3. Log 17 over log 3. Yes?
When you did I remember you showed us like a shortcut where it was like,
Change a base.
it was like something like that when you divide the logs, but you don't have to write out the logs, just do the division.
Yeah, I will show you. Technically, typically, I don't do it when it's written like this. I do it when it's written like this. Log base 3 of 17. If they ask me to simplify this I would use the change of base. Log of 17 over log of 3. That's the shortcut. If you forget to change your base, make it equal to x, do the wraparound to this, and do log of both sides. Either way is going to work. This is the quicker way, the change of base. But if you don't remember it, wrap around and log of both sides. Right, when it's like this. And you're like, oh, I can't plug that in my calculator. You can do the wraparound. She was saying there was a shortcut. It was called the change of base, which you could use. You don't have to.
If you do that, you can just divide it by.
Yeah. If they give you this and they ask you to simplify and you're like 3 to what power 17? I can't do that. Then you do change of base. Log 17 divide by log 3.
So you don't really ever have to do this.
The log of both sides. It's the log of both sides that we do instead. All right. There was a hand up over here when I answered her question. No? No hands up? I was seeing things. Yes.
On the last question, where did you get 80?
Good question. Can anybody answer? One of you guys gave it to me. Where do we get the 80? It says find the amount of time, the number of hours for the half-life, while half of 160 is 80. Because half-life means you end up with half of what you started with. If it said find how long for you to end, I mean, I never asked this, like the quarter life, then you would divide by 4. All right? Yes.
Give it a problem with it has continuously.
A problem with continuous? Yes. After this, we are going to get started, and it's like a typical test. I don't know about that.
Yeah, first time.
Have you been back there the whole time? Have you been back there the whole time? I didn't see you. There's no Draco Jackson. Can you hand me that yellow notebook on my desk?
For the graphing portion, we just have to know whether it's decaying or growing.
And what the graph looks like, when, like growth versus the decay. When is it growing and when is it decaying, and what does it look like? All right. Okay. Are you guys ready? A question was, a compounded continuously if $25,000 is invested at 8.5% interest, compounded continuously. How long, what am I looking for? If I'm asking how long does it take? time. How long does it take for the investment to quadruple in value? All right. A equals PE raised to the RT. P is the initial. Did they give us the initial amount? E is a number in your calculator. Did they give us the rate? So 0.085 times T. Do we know T, or is that what we're looking for? And how long does it take to quadruple? What does it mean to quadruple? 25,000 times 4, which is 100,000. All right. I want to solve. What do I divide both sides by? And what do we get? 4. I want you to think about this for a second. They gave us the initial amount, but even if they didn't, would I still end up with this? I need you guys listening. If they did not give initial amount, what would I put here for P?
1.
And then quadruple, this would be 4. So do you see why when they don't give you initial amount, why we do that? And it still ends up the exact same way if they did give us the initial amount. Okay? All right. I want to solve for T, and T's in the exponent.
So you have to take ln of each side?
Take ln of each side. Do you guys agree with him? Take log of both sides, but since it's base E, we're going to do ln. ln of 4, a decimal in your calculator. ln of E of 0.085t. And what do we do with this? To the front. ln of 4 equals 0.085t. ln of E. Two things you can do. Yes. Remember that ln of E is 1. If you forget and you divide by ln of E, still get the same thing. Kids are like, how do I plug this in? You would do ln of E raised to the first power. But it's easier if you just remember this is 1. ln of 4 equals 0.085t. What do you do? And plug that in your calculators just to see what you come up with, to see if you know how to plug it in. We're looking for the amount of time. Let's do 3 decimal places. 16.309 years. All right, we're good.